Hello everyone. Uh, Today we will study about the IoT design methodology in which we will study about the various steps involved. What are the various steps we have to follow to get our IoT application implemented and deployed on any system. IoT design methodology. IoT design was nothing but the steps followed for implementing our IoT application in various phases, in which the first phase is purpose and requirements. It basically defines the purpose and requirements of the IoT system. What are the requirements? What are the requirements of the client? What are the requirements of the product? What is the purpose behind it? Second one is process model specification. It defines the various use cases, defines the use cases involved in our activity diagrams. Third one is domain model specification. It defines physical entities, virtual entities, devices, resources, and services in the IoT system which are used. What are the physical entities involved, virtual entities, what are the devices involved, sensors, actuators, and what are the resources and services involved in the IoT ecosystem of ours. And next one is information model specification. It defines the structure, for example, relations or any attributes of different types of all the information in the IoT ecosystem. Defines the structure of all the information present in the IoT system. Next one is service specifications. It basically map process and information model to services and define services specifications. It basically map different processes and information models and define what are the various guidelines, rules, specifications we need to follow. Next one is IoT level specification. It defines the IoT level for the system. Next one is functional level specification. It maps IoT level to functional groups. Next one is operational view specification. It defines communication options, serving hosting options, storage options, device options, where we have to host, how do we have to store, what is the communication protocol used, what are the devices options. All this thing is described here in operational view specification. Next one is device and component integration. In this, we have to integrate devices, develop and integrate the components involved in our IoT device or application. Next one is application development. In this, this is the final stage which the user connect to it. We have to develop the application UI interface of our product, and further so the user can use it. Step 1 in our IoT design methodology is purpose and requirement specification. The first step in IoT design methodology is to define the purpose and the requirement of the system. This step basically the system purpose, behavior and requirements such as data collection requirements, data analysis requirements, system management requirements, data privacy and security requirements, user interface requirements are captured. In this step 2 is process specification. The second step in the IoT design methodology is to define the process specification. In this step, the use cases of the IoT system activity diagrams are formally described based on and derived from the purpose and requirement specifications. Now the step third involved in the IoT design methodology is domain model specification. The third step in the IoT design methodology is to define the domain model which we are going to use in our IoT design methodology. The domain model basically describes the main concepts, entities and the objects in the IoT system which is to be designed. Domain model defines the attributes of the objects and the relations between the objects. What are the attributes? What is the relation between them? It describes all these things in domain model specification. Domain model provides an abstract representation of the concepts, objects and entities in the IoT domain, independent of any specific technology or platform. With the domain model, the IoT system designers can get an understanding of the IoT domain for which the system is to be designed. Step 4. The step 4 in the IoT design methodology is information model specification, which you have which is depicted on the first slide of our lecture, the diagram in which we have in the arrow one. This is the fourth step. This is the fourth step in the IoT design methodology is to define the information model. Information model is nothing but it defines the structure of all the information in the IoT system. For example, attributes of virtual entities, relations, etc. Information model does not describe the specifics of how the information is represented or stored. To define the information model, we first list the virtual entities defined in the domain model. First, we have to list the virtual entities defined in the domain model. Information model add more details to the virtual entities by defining their attributes and relations. It also defines their attributes and relations. The attributes and relations of the virtual entities are also defined by the information model. The step 5 followed in the whole process of IoT design methodology is service specifications. The fifth step in the IoT design methodology is to define the service specifications. In this, the service specifications, define the services in the IoT system, like services types, services inputs, output, services endpoints. What are the endpoints of the services? What are the schedules of different services? What are the preconditions we have to follow of different services? What are the effects of these services? The fifth step in the IoT design model is to just define the service specifications. The services which we are using, what are their specifications? In this step, these are all followed. Step 6 in the IoT design methodology is the IoT level specification. The sixth step in the IoT design methodology is to define the IoT level for the system. Step 7 in IoT design methodology is the functional view specification. The seventh step in the IoT design methodology is to define the functional view of our IoT ecosystem. The functional view defines the functions of the IoT systems grouped into various function groups. The various functional views defines the functions of the IoT system grouped into various FGs, functional groups. Each function group either provides functionalities for integrating with instances of concepts defined in the domain model or provides information related to these concepts. Step 8 in IoT design methodology is operational view specification. The eighth step in the IoT design methodology is to define the operational view specifications. In this step, various options pertaining to the IoT system deployment and operation are defined. How we have to deploy our IoT system, such as how the operations are defined, such as serving hosting operations, service hosting operations, storage operations, device operations, application hosting operations, where we have to how we have to host our application, etc. involved. Step 9 in the process of IoT design methodology is the device and component integration. The ninth step in the IoT design methodology is the integration of the devices and components involved in our IoT system, which we can further connected and they can share and exchange. The 10th step is the application development. The final step in the IoT design methodology is to develop the IoT application, which you have to host and in which the user will interact with it is the application development. And that's the last step for IoT design methodology. Finally, we have to integrate the system. First step is to set up the device, deploy and run. An example of any application how we have to integrate the system is in this slide. The setup, first we have to set up the device, deploy and run the REST and native services which we are using in our IoT product or device, deploy and run the application on our host, and the set up the database. The OS running of Raspberry Pi, it's an application scenario which is in the diagram. First one is a local app. It's on the Django application, which is using REST services, REST call, which are further connected to the database, having control services, resources, and devices. REST service can be the REST APIs, which are used to fetch data from the database or from any server. The database uses SQLite database in this example of integrating the system. Control service can be native service implemented in Python. Resource can be OS running in Raspberry Pi. Raspberry Pi device can be Raspberry device to which sensors and actuators are connected. So this was an example of any system which we have to how we have to integrate it. So thank you everyone.